video on ellipses. Well, maybe we can call it ellipse part 2. Notice that we said that this was, let's say, an equation of an ellipse. Okay? With major axis x. Okay? Alright? Let's redraw it here, just for good measure. Okay, over here it's a negative a is 0, positive a is 0, 0 positive b, 0 negative b. The focus here is c 0. Focus here is negative c 0. Okay? Here's our ellipse. But notice it's centered right smack dab in the origin. What if we wanted to draw an ellipse that looked kind of like this? Right? What if we wanted to do this, huh? You know, what would this point be at? What would this point be at? You know? How could we express such an equation? It really looks like we got this ellipse, shifted it to the right a little bit, and shifted it up a little bit. Does it not? Yeah, that's precisely what we've done. Recall that a vertical shift can be done to a function. If you add or subtract a constant, it'll vertically shift the function. However, whenever you add or subtract quantities inside the function, it will horizontally shift it. For instance, recall our beloved circle, since most of you guys are familiar. Our beloved circle centered at the origin is x squared, y squared. With unit radius, it would be 1. But if we wanted to shift such a circle, if we wanted to move this circle to down here, okay, here it's centered at the origin. Let's say we want it centered at 3, negative 4. We can just shift this equation right here, transform it like so. We'll make it x minus 3, quantity squared, for the shift to the right, plus y plus 4 quantity squared is equal to 1. The plus 4 shifts it down 4, and the minus 3 shifts it to the right by 3. Yeah, I know, it's counterintuitive. If this plus 4 was on the outside of this, it would shift it up. But here, since the plus 4 is on the inside, it scoots it down. If this minus 3 was on the outside, it would vertically shift it down. But since this minus 3 is on the inside, it horizontally shifts it to the right. So, you got to keep that into account. Now, that's with circles. Can we translate that to ellipses? Absolutely, we can. Remember, the standard form of a circle was x minus h quantity squared plus y minus k quantity squared is equal to r squared, you know? Here, we can translate such an ellipse. This is centered at 0, 0. But we can center it elsewhere. We can center it at hk. To center it at hk, we can shift it like this. X minus h quantity squared all over a squared plus y minus k quantity squared all over b squared is equal to 1. And now we've shifted this. This was shifted. This was centered at the origin. This is now shifted. And now this ellipse is centered at h comma k, where right here it would be h on the x, and right here it would be k on the y. Okay? So we can shift the center of an ellipse. But I know what you're thinking. Well, man, now what is this part? Before, this part was just a0 and negative a0, and the foci was just c0, negative c0. How do I know what the foci is here now? How do I know what these are? How do I know? How do I know? Well, it's quite simple, my friends. Since the whole ellipse got shifted by a specific quantity in each component, you just add that specific quantity to each component. What do I mean by that? It sounds kind of nebulous. The statement sounds kind of perplexing, but it's not. Actually, all we require is just, if it got shifted to the right by h, everything that had a component on the x because it gets shifted horizontally, that means the x is being shifted. That means we need to change this a to a plus h, okay? Furthermore, we need to change the 0 to 0 plus k, because notice it got shifted to the right by h and up by k. So we modify this piece. This becomes a plus h, because we scooted it to the right by h on the x. And on the y, we just added a k. So it went up by that. It's very easy to transform this to that. We just look at this and step by step change it. It was like this originally, but then we shifted it by h in the x, and then moved it up by k in the y. Done. Now what about this one? Well, that one used to be a negative a 0, but still we added k to it to shift it horizontally. So it's negative a plus h in the x. And in the y, what did we do? Shifted it up by k. So that's where that new point is at. Okay? What about these points? Well, they were originally at 0, negative b, 0, positive b. But look, now it's just at h, negative b plus k, because it got translated by h on the x. That's why it's no longer 0, because it moved over by h on the x. And now it's no longer negative b only, it's negative b plus the k, because we scooted it up by k. And over here, at this point right here, it'll be at h comma positive b plus k. Alright? So now we know those values. What about the foci? What about the foci? This foci right here, and since it's getting kind of cluttered, I'll write F1 to this, and I'll write F2 to this, okay? F1 used to be, the original F1 over here was negative C0, but it got shifted on the x by h, so it's going to be at negative c plus this shift in the x. Furthermore, it had no y component, but it did get shifted up by k, so 0 plus k is just k. So we'll put that right there. And what about F2? Well, F2 was C0, but we can't just leave it at C0. C got shifted in the x component by h, and in the y, it got pushed up by k, which is 0 plus k is just k. Alright, so now we have the ability to translate any ellipse, okay? So, let's actually apply this to a real situation, alright? Let's actually apply this to a real situation. I'm going to erase all of this, and I'm going to create an example. What if we say, graph x minus 2 quantity squared all over, let's say 36 plus y minus 1 quantity squared all over, let's say 16 is equal to 1, so that it's an ellipse, okay? Notice this is an ellipse centered at 2, 1, alright? This is an ellipse right here. This is an ellipse centered at 2, 1. This is where it's centered at. Okay? So now notice, what we can do is we can actually treat this shift with the appropriate facts here. My suggestion to you is act like the ellipse has not been shifted at all. What do I mean? Alright? Ignore this 2 and ignore that 1. Treat it like your old-fashioned ellipse centered at the origin. Okay? Solve the problem like that. Forget about the 2, forget about the 1. Solve the problem as if it was centered at the origin. This is centered at 2, 1. But this is centered at the origin because we set h and k equal to 0. Now it's clear that this is an ellipse. Looks like 36. A squared is 36. Looks like 16. B squared is 16. this implies that A is equal to plus or minus 6, and this implies that B is equal to plus or minus 4. So, okay, the major axis is on the x-axis because the number in the denominator from x squared is the larger number out of the two. Alright? So it looks like if it was centered at the origin over here, this would be at 6, 0, negative 6, 0. This would be at 0, 4, and this would be at 0, negative 4. Where are the foci? Let's find these foci. C, recall, is equal to plus or minus the square root of b squared, or a squared minus b squared. A squared minus b squared. We got to do a squared minus b squared because a is the larger number, and this ensures we don't take the square root of a negative number. Alright, so then c is equal to plus or minus the square root of 36 minus 16, which I think I could do this one. This is plus or minus, take the 6 away, take 10 away, this is 20. Alright, plus or minus the square root of 2 times 10. Plus or minus the square root of 2 times 2 times 5, so it becomes 2 plus or minus 2 root 5 here. So c, we get a is equal to these, and c is equal to plus or minus 2 square root of 5. Okay? So over here, this is at 2 root 5, 0. This is at negative 2 root 5, 0. Alright, but we're not done, okay? Because we haven't really solved the original problem. We were supposed to graph this, we're supposed to graph the shifted ellipse, not the centered at the origin ellipse. This is centered at the origin. We're supposed to graph it shifted. I'm telling you, it's actually quite easy to do the rest now. And to commemorate such a bold claim, I will switch colors. Okay? I'm feeling like blue today. Alright? Notice that all that we need to do is shift all of the x's over by 2. All of the x components in every piece of information. This. All of their x components need to be shifted by plus 2. And all of the y components of this need to be shifted up by positive 1. If we do that, then we would have graphed this whole thing appropriately. So let's start off on the left. Okay? This negative 6, 0, it needs to get transformed to a 2 plus negative 6. So negative 6, 0, I need to add 2 in the x component and add 1 in the y component. It needs to turn to negative 6 plus 2, 0 plus 1. So this is equal to negative 4, 1. So now, where is negative 4 here? Okay, 1. So that's where that new point goes. Alright? What about this piece? Okay? This piece is now going to go from 0, 4. I gotta add a 2 here, plus 2, and I gotta add a 1 here. This becomes 5. So this goes to 2, 5. So this is at, let's document it. This is at negative 4, 1. This is at 2, 5. Alright. This point, 6, 0. Well, 6, 0. I got to add 2 to 6, so that's 8. And I got to add 1 to 0, that's 1. So this gets shifted over here to 8, 1. What about this guy? Well, very easily, 0, negative 4. I need to change it. I need to add 2 in the x component. I need to add 1 in the y component, so it goes to 2, negative 3. So I get shifted here to 2, negative 3, right here. Okay, so that's the 4 upper corners, all the vertices along the top. Now let's shift the foci. Negative 2 root 5, 0. I need to add a 2 to this piece, so it becomes 2 added to that, so it's minus 2 square root of 5, comma 1, because 1 plus 0 is 1. So this piece gets shifted right here. This is going to be at minus 2 root 5, comma 1. And this piece gets shifted to 2 root 5 plus 2, comma 1. Right here and right here. Okay? Notice that when I connect the dots here, I get a phase, a shifted ellipse. It moves to the right by 2 and up by 1. I know it doesn't look the prettiest because I'm not the best artist in the world, but mathematically speaking, we have documented how each of the points is shifted due to the graph transformation. So now you know how to be able to graph a shifted ellipse. It's just like graphing the normal ellipse. Graph it normally and then additively change how it moves in the x in each coordinate and how it moves in the y in each coordinate.